All right, good evening, everyone. All my wonderful guests for this meetup of the Spokane Python User Group. My name is Joseph Riddle. I'm the current organizer of the Spokane Python User Group. And today we're going to talk about background task processing in Python, focusing on the libraries Celery and Dramatiq, respectively, or Dramatiq, and how they compare to each other and some of the use cases and just all that good stuff. For anyone who fills out this feedback form on the for feedback on the Spokane Python user group, you will be entered into a raffle for a JetBrains subscription. Questions on there include what kind of topics you're looking for in the meetup, and some other good stuff in there. So I'll paste that in the description below. And moving on. Some stuff we're going to cover today is use cases for libraries like Celery or Dramatiq. We're going to cover some high-level definitions for things that relate to background task processing, both specific to Python and not specific to Python. We'll talk about what is Celery, what is Dramatiq. We'll look at some differences between them, and then we'll do a light demo towards the end. So without further ado, let's get into it. So before we get too in the weeds, here's some use cases for something like Celery or Dramatiq. If you have tasks in Python that are I/O bound or CPU, GPU bound, it does present use cases for both of those. Couple examples include if you have a web API using like Flask, Django, Fast API, and you want to do some background task processing, so that you're able to return a response to the API client right away, but still want to have some stuff running in the background. These libraries work well for that, kind of similar to Hangfire in C# and probably some similarities to some other libraries as well. Some examples of background tasks you might be doing include sending emails, connecting to other APIs, or other long-running tasks that are I/O or CPU bound. On the CPU, GPU bound side of things, you might use it to do some distributed machine learning across multiple workers on different machines. You can also host it in the cloud and use things like Azure or AWS to scale up and down. And you can also do, to some extent, scheduling tasks, though there are some caveats to that we'll touch on later. So some definitions before we get into what Celery and Dramatiq actually are, is we're talking about background task processing. So a couple of things we want to define before we move forward are, what is a message? And so in our case, a message is kind of not like concretely defined, but it's a unit of communication between computer processes. So what that looks like could differ from protocol to protocol. One popular protocol is AMQP. I'm not sure the right way to say that, but that's a popular one that RabbitMQ uses. It also supports some other protocols. And for the purpose of our talk today, a task is just any asynchronous unit of work. So something that, like in the use cases for like the API, a task would be something that you want to run in the background, separate from the synchronous process of returning a response to your client. A message queue provides fast asynchronous communication between software components. So in this case, software components is intentionally vague in that it could be different programming languages, different frameworks. A message queue is in some ways agnostic to what you're connecting to it, depending on the specific message queue implementation. Another definition of a message queue temporarily stores messages with endpoints for software services to connect to the queue. Kind of a diagram of what that looks like. Here you'd have on the left producers, things that are creating messages and sending them to these queues, and then consumers would be pulling the queues out, or pulling the messages out of the queue. This is a pretty simple diagram. In some cases, you might have consumers are also producers and vice versa. but this just kind of gives you a little bit of an insight into what a queue kind of looks like. So building on top of a message queue, you have something called a message broker, which at a high level is an architectural pattern for message validation, transformation, and routing. Kind of some buzzwords, but what that really basically comes down to is it provides a way to have decoupled communication. A message broker basically facilitates different services connecting to your message queue. Really popular ones include RabbitMQ, Apache Kafka, there's a whole bunch of other ones, as well as all the major cloud providers have some hosted version of a message broker. Some of them I think are just wrappers around Kafka or RabbitMQ. Google PubSub might be its own thing. I'm not sure off the top of my head, but we'll look into some specific use case, some specific examples of RabbitMQ and Redis when we look at code samples. RabbitMQ is probably the most popular open source message broker. Like I mentioned earlier, it supports some popular open source messaging protocols such as AMQP. And fortunately for us, it does have a Docker image, which we'll use in our code to spin up a RabbitMQ container on our local machine and use it with Celery and Dramatiq. This is getting a little bit in the weeds and not super necessary to know for what we're talking about today, but AMQP, Advanced Message Queuing Protocol, basically just an open source standard for passing messages between applications and services. If you want to learn a little bit more about it, which is not necessary to use Celery or Dramatiq, Celery does have a good kind of quick intro or primer, which is linked in this slide. It is also it recently, or I'm not sure exactly when, but in the last few years, it did become an internet standard. So you can go take a look at that if you want. Also linked below. Another maybe not so thought of message broker, or not one that might come to mind, is Redis. Redis traditionally thought of basically a cache or a data store, which is end memory, but it can be used as a message broker. And it also has a Docker image, which we're going to use along with our RabbitMQ image to kind of show two different message brokers we can use when we're working with Celery or Dramatiq. So Celery, kind of one of the two things that we're talking about today or focusing on is a Python library that provides open source asynchronous task queue or job queues. It does focus on scheduling, like I mentioned earlier, but it really focuses on real time. Its scheduling is not incredibly robust. That being said, Celery is kind of the standard for a Python task library. It's been around since 2009 and is certainly the most popular one. There are others, but Celery is the most common one and probably the most documentation is out there for it. Just for reference, it has close to 20,000 stars on GitHub, just a unit of measurement when we compare it to the next module we'll look at, Dramatiq. So Dramatiq is another background task processing library, also in Python, that was created by a guy who used Celery a lot and found that some of Celery's defaults really caused some frustrations. Things like not automatically retrying tasks and some other stuff. Just eventually he decided to create his own, and I think Dramatiq is the second or third most popular Python task management library behind Celery. So if you do use Celery, you're familiar with it, and you keep running into some frustrations, Dramatiq might be worth taking a look. Or if you haven't used either and you're looking to just skip over Celery and try something that's a little bit newer, definitely worth a look. At the end of the presentation, I will have some links to some other task processing libraries in Python that are worth taking a look, but Celery is definitely the most popular, followed by only a couple others, and then there's a lot that aren't super widely used. As you can see, this was created in 2017, so it's definitely newer. That being said, it has seen active development and maintainment, and so is Celery, even though Celery is quite a bit older. So the title or subtitle of the talk, Celery versus Dramatiq, what are some differences? They both support most of the major messaging brokers, RabbitMQ, Redis, and they both provide a way to go and write your own broker support. These are just the ones that are already created or included out of the box. One thing that Dramatiq does have out of the box that Celery doesn't is in-memory. So it basically uses in-memory storage to store the messages that are getting passed back and forth. Another thing that you might use when working with Celery or Dramatiq is a result store. So basically when you run your asynchronous task, if you choose to, you can store the result of that task, which might include some metadata about the task or a result itself, maybe an ID of something generated or some other object. This is where Celery actually, being older and a little bit more mature, has some more options out of the box versus Dramatiq. They both have Redis, memcached, but Celery also has MongoDB, the file system, and more. Something worth noting for Celery and Dramatiq is that they both recommend generally RabbitMQ or Redis as the broker, and they both also recommend Redis or memcached as the result store if you do decide to use a result store. While Celery does support MongoDB and the file system and some other stuff, generally recommends using Redis and memcached. Looking at some other differences as far as capabilities go, just a couple high level differences. They both do support scheduling of tasks. Celery uses it through a built-in feature called Celery Beat. Basically, you would just run a separate worker that is run using Celery Beat from the command line instead of Celery worker. And it just uses, I don't know what it uses internally, I think cron, to basically run a task every day or every week or however often you want it to run. Dramatiq, on the other hand, doesn't provide any scheduling out of the box, but it does say in its documentation that you can accomplish scheduling using a separate module, AP Scheduler. I haven't used AP Scheduler, so I don't know that much about it, but it is available. So maybe worth taking a look if your primary use of Celery or Dramatiq would be scheduling tasks to run at a certain interval. Monitoring, obviously they're both, you can monitor from the command line through looking at logs, but as far as some sort of graphical interface, Celery offers something called Flower, spelled flower, but pronounced Flower. Basically provides a nice UI through a local web app to be able to look at the tasks that are running, the tasks that are scheduled, as well as it exposes an API if you don't want to use its UI, but still want to manage Celery via the web. It also allows you to do things like revoke tasks, increase the number of workers, things like that. It's definitely a tool that I think has a lot of capabilities that I haven't even fully explored yet, but it has been helpful for me on a project at work to monitor Celery in an easy way. Dramatiq does have monitoring. That being said, its options aren't great. Both of the more popular libraries, Dramatiq Tasks with monitoring being one and Dramatiq Dashboard being the other, are not very mature. They don't see a ton of development. They do exist and you could probably use them, but I've not used them and don't know that I'd be comfortable using them in a production environment. There's also other things you could use to monitor these that aren't specific to Celery or Dramatiq, such as Sentry, or just if you're running a Docker container, you can use the logs from the Docker container and forward those to some other logging or monitoring service. Chaining, so what I mean by that is like running one task when another one completes, grouping tasks together, callbacks, that kind of thing. They both do support, though the way they go about it is slightly different, but pretty similar. If you want to look at some more differences, Dramatiq on its website actually has a pretty good breakdown between the two, though it is, I think, a little bit, being on Dramatiq's website, a little bit more favorable towards Dramatiq. Another thing is Celery released a version 5, a major version 5 relatively recently, and I'm not 100% sure if that motivation comparison table takes into account some of the newer stuff in Celery 5.x. So worth taking a look, but I wouldn't take it as capital T truth. We'll look at briefly some code just in the slides, and then we'll hop into VS Code and play around with it a little bit. But as far as the minimum amount of code to get Celery going, you just import Celery, create a Celery app, and then use a decorator on a function to define something that is exposed to Celery as a background task. This is assuming you have a broker running. In this case, it's RabbitMQ, though you can also use Redis or some of the other brokers we talked about. Dramatiq actually looks really similar. They both use decorators for their functions to basically declare a function as a task to the respective library. In this case, there's just really one extra step, which is creating the broker explicitly and then using setBroker to set that as the global broker for Dramatiq. You could probably combine that to one line though and have basically the same amount of code to get a really minimal app running. Let's hop into VS Code and run through some examples, and then we'll come back over to the slides. I will link the Git repo and all the example code below or in the description of the video. And let me link it for our viewers, our live viewers. There you go. All right. So if we take a look at VS Code, I'll bump that font up a little so it's easier to see. We'll see a terminal that's running marp, which is actually converting my README from Markdown to HTML, which is the presentation I was showing. So we don't really care about that. We can hide that, and we can hide the Markdown README. First thing I'll show is inside of our folder for this presentation, we have a couple things. Docker file, Docker compose file, which I'll go over in a moment. Requirements file just has some Celery, Dramatiq, and requests, the ubiquitous Python request module. And then inside our source, we have two modules, Celery demo, Dramatiq demo. Within each of these, we have just some fairly basic code. You see we have this count2 function in our Celery demo, which we saw in the presentation slide. And we have the same functions defined in Dramatiq, but using Dramatiq instead of Celery. So we'll come back to this code in a sec, but what I want to show you, because if you're like me, you use Windows day to day, and Celery and Dramatiq don't always work 100% well with Windows. Fortunately, we have Docker, and we can just run both of them in Docker, and then we have a Linux environment. So in our Docker file, I defined a custom Docker file for our specific code. There are both a Celery and a Dramatiq Docker file on Docker Hub, but since we have our own code, we're just creating our own image from the base Python file, Python 3.9. So quick overview of the Docker file. All we're doing is adding our source code folder to the Python path so that when we run the code inside of the Python container, it is able to find our app code. We install the requirements from our requirements.txt file. And then here we're actually using Docker stages to define a base image from Python 3.9 as base. And then we're using base as a jumping off point for both Celery and Dramatiq to define basically two different paths we can go. So in this case, I was a little lazy and just created one Docker file to keep things a little bit simpler, but we're able to use it to either run Celery or Dramatiq because they're both built off the same code base for this meetup. Here we can see that we're running Celery as the entry point to the Celery container and passing just a couple command line arguments. We're giving it the path to our project using -A to the Celery demo folder. Subcommand worker is basically just saying, hey, create a Celery worker, which is the main logical unit in Celery. And then just to make it a little easier to see exactly what we're doing when we're running Celery commands and stuff, we're going to up the log level to debug. I think the default is info. Basically the same thing with Dramatiq. We're using -- verbose to also get the log level of debug. And in this case, we're also just passing it the path to the Dramatiq demo module. Bouncing over the Docker Compose file just to show you how because I'm using Docker Compose basically wrapped around the Docker file. We're defining a couple services to be able to run this demo repo. Celery, we define that we want to build our Celery image using, and then we're going to name it background tasks -Celery latest. We're going to mount our source code volume inside of the container when it runs. That will allow us to make changes to our Celery, some of our Celery functions, and without having to rebuild. Though we will, generally speaking, still want to restart the container to get that updated code just because of the way Celery works. But there are some things you can basically hot reload. It just depends exactly what you're changing. We're going to set the working directory to our source code volume, pass an environment file, which has just a couple environment variables. Nothing too crazy. Basically the same thing with Dramatiq. In this case, we're targeting the Dramatiq image instead. This is defined in our Docker file. Same thing with the Celery. We're targeting the Celery image, or Celery stage, excuse me. A couple other things we have running. Just a normal Redis container, pulling the Redis image from Docker Hub. Same thing with RabbitMQ. And Flower, as I mentioned earlier, the GUI to view Celery tasks and workers. So now that we have some of the Docker stuff out of the way, let's make sure we have our Docker Compose file up and running. I have an alias on my machine for Docker Compose to DC because I'm lazy and don't like typing Docker Compose, so I'm just going to use that. First, let's make sure we have our up-to-date images. So we'll do DC build or Docker Compose build. Oh, and make sure that I am inside of the right folder. In this case, it's the 2021 background tasks folder. And I'm also using a virtual environment in my case, though that doesn't really change much of anything. It just doesn't pollute my global Python modules. So we'll do DC build. You can see that I've built it before, as there's most of the stages are cached. We already have the Redis image pulled down, the RabbitMQ, the Flower image pulled down. So we have our up-to-date images. Let's go ahead and do Docker Compose up, and we'll do -D, run them in detached mode because we don't want to see all of the logs from all of the images. After a minute, we'll see that all the containers started. We'll do Docker Compose PS just to verify that they all are running. Yep, we can see from the state that they're all up. So if one of them had an error with its startup entry point in commands, we'd see exit, whatever. Or if in our Docker Compose file we had it set to restart always, you'd probably see it just constantly trying to restart. Just adjust myself over here a little bit. Whoops. Need the link to that. And let me just respond to some live comments. There we go. Now I'm more in the corner. All right, hopping back in our example code, we see that all the containers are up and running, so that's great. Let's take a look at some of the logs from the containers, get a feel for what they look like. All right, so when we look at the, Celery containers logs, because we have it set to debug instead of just info, there's actually a lot more information getting printed out here than we really care about. The main thing that you'll see when you have the even set to just info, you'll see a list of tasks. Most of these are just built-in Celery tasks, though in this case, we do have a couple from our Celery demo, our functions that we marked as Celery tasks, count to, count words, get URI contents. Those are all there, so that's great. And we'll also see this neat giant C in our logs and just a couple things to indicate, hey, we're using Redis as our transport or our queue backend, and some other debugging info we don't care too much about, but basically what we're looking for is, hey, Celery's ready to go. Celery was able to connect to our broker. Everything looks good. Take a look at the Dramatiq logs. Oof. We also have it set to verbose, so we'll see a lot. But again, mostly what we're looking for is running worker thread, ready for action. Everything looks good. We don't see any errors. You can see that it's started up, I think by default, as many worker threads as, it'll start 2 worker threads per CPU core you have. In this case, I think I have a 4-core machine, so it looks like we have 8 threads ready to go. Yep, 1, 2, 3, 4, 8. Looks good to me. So let's go ahead and run, actually, a command instead of just looking at it. What I'll do is I'll do DC logs-f for follow, and then we'll run the Celery first. So now we'll get some output when we actually run a command. I'll minimize this and create a new terminal and move it up here. So if we make sure to navigate to the right folder, and then we'll enter our Celery container. You could have a separate, if you had some sort of API container running, like Flask or Fast API, you could also enter that container and run the tasks from there. It would work from there if you had them both on the same Docker network. In our case, we don't have like an API running, so we're just going to hop in the container that's running itself. What we'll do is go ahead and run the Python module for our Celery demo, and I'll show you what that code looks like. Inside of our Celery demo module, we have a dunder main defined, and we have our example 1 uncommented. Basically, what we're doing here is calling the function count2 defined in our Celery demo file. But because of the dot delay at the end, that's basically saying, hey, go ahead and submit this as a task to run in the background of Celery. If you just wanted to run the function as normal, you still can. You just call it as a normal function and remove the delay. And that's great for unit testing if you want to test a function that's decorated as a Celery function, but not run it through all the Celery stuff. That's an easy way to do it. So back over to our other console, we'll go ahead and run that. In this case, we're printing out the task ID, and here we'll see, looks like everything's connected. This task or this function isn't doing anything too interesting. We're just saying, hey, let's print out that we're running. And in our case, we're just printing out the number, the numbers leading up to the number passed in. So in this case, 0, 1, 2, 3. And then we can see here that the task finished successfully. So everything's connected, good to go. Now, that example wasn't really super interesting. There's probably this is definitely overkill for Celery. If you're just trying to get the range of numbers I through n, you don't need Celery. But maybe you have an API running and you want to do something like go get the contents of a web page. So in this case, we have request.get, and we were going to pass in a URI and go and download the contents of that website. And then just for fun, we're also going to count the number of words in that website's HTML. So this is kind of showing two things. A, getting the URI contents, especially if you're accessing a slower website, could take a while. And if you have an API and you're trying to return a response to your client as soon as possible, you don't want them sitting around waiting for some other process to finish potentially. So in this case, you could return your 201 resource created, give them an ID to go be able to look up, or if you're using WebSockets or something, you could just return the ID immediately and then keep that WebSocket connection open while you run this task in the background. There's a couple different ways to go about it, but long story short, we're able to do something that's actually sort of interesting that you would probably want to do in the background, especially if you had an API using, well, in this case, we're actually in the Dramatiq demo. Let's hop over to Celery demo. Same function defined here, just using the Celery syntax. So we're just going to comment out example 1 really quick. Comment in, uncomment example 2. In this case, we're just grabbing the first command line argument passed to the module. And then we're doing, here's another thing I want to show you. I mentioned in the slides that you could do chaining. And so this is showing we're going to do one Celery background task. We're going to go and get the URI contents, or the contents of that website. And then we're going to pass the result of that task over to our other defined task, count words. And so this basically allows you to define all these separate tasks, that do one specific thing really well, but maybe you want to bring them together and you're able to chain them. And there's a ton of other functionality built in Celery. You can chain, group, callback, do some error handling logic, all sorts of stuff. But for the sake of this demo, we'll just stick with this. In this case, we don't need to actually restart the Celery container because we're not actually changing any of the tasks that are running. We're just changing the how we're calling the tasks. So in this case, because we've mounted our source code volume into the Docker container, we should just be able to, back in the container, we should just be able to call our Celery demo module again, and this time it's going to run the function that we uncommented. If we run that, we'll see, as expected, an error because we didn't pass in any command line argument, and we're expecting one, and we didn't add any error handling logic to basically handle if you didn't pass in a command line argument, which is fine for this example. All we need to do is just pass in command line argument. Let's do google.com. That seems easy. Or even better, we'll do example.com, a website created for exactly this purpose. All right, we didn't return anything, so nothing, we don't see anything here, but I accidentally stopped the login, so let's restart it. And I'll run this function again. And boom, there you go. You can see that we're actually printing out the result of the tasks. We don't necessarily want this always, but because we have the log level set to debug, it's just logging a lot of stuff. And let's hop back over to our count words function. And we should be seeing that count words is also counting the number of words and printing that out. So there's so much stuff in the console that it's kind of hard to find. Looks like it might not be printing it exactly the way we want to. Let's go ahead and try and change that return to or change that print to return. And then we should get it in our output. So in this case, I will restart the Celery container really quick because we are changing the tasks that are the actual contents of the tasks. Grab the logs again. We're still going to have all those logs we had before. But if we hop over to our second command line instance, we'll enter the container again. We'll run our Celery demo module correctly. And we'll go ahead and pass in example.com. I'm not seeing the chain task in the output, which is interesting. We'll wrap back around to this if we have time towards the end, but chaining does work, and I probably just have a bug in my code. But for the sake of time, I'll move on and show you some of the Dramatiq demo, and if we're good on time towards the end, I'll wrap back around to this and show you that chaining does work. Go ahead and stop. And we'll stop following the logs for the Celery container, and let's hop over to the Dramatiq container. Oh, if I can spell it right. All right, so we see the Dramatiq container is running. It's got worker threads ready to go, looking for work to do. And so let's open up the Dramatiq main. You can see we have basically the same code going on here in our main for the Dramatiq demo module. In this case, the syntax is just slightly different. Instead of calling .delay or apply async, the Celery code to run something in the background, we use .send, also on our function with the Dramatiq decorator. So if we hop out in our second console we have pulled up, we'll exit the Celery container. Instead, we'll enter the Dramatiq container. And now we're inside the container. And we'll go ahead and run the Dramatiq demo. And we'll spell it right this time. Boom, there you go. So we see here, we have a task ID. That's great. And we can also see in the Dramatiq logs that we're getting the same thing as the example from the first part of the Celery demo. 0, 1, 2, 3 printed out. Task is completing. Everything looks good. Right on. Let's check out the second demo. So again, we'll just comment out that code really quick for the first example, uncomment the second example. Again, list index out of range. When we rerun it, use URL, boom. In this case, you can see, hey, look, because we have that verbose logging on, we're printing out the result of the task. In this case, we're returning the URI contents. You can see example domain in the header, etc. We're also seeing here the chaining taking place. In Dramatiq, it's called a pipeline. Same basic idea, though. You can chain tasks together and run them in sequences, or even in parallel if you want to do a group of tasks and wait for them all to finish. All sorts of different things. And you can see there are 298 words at example.com. If we actually go over to example.com, you can see it looks like there's less than 298 words, but we're actually not just grabbing what's viewable, we're grabbing the entire content. So yeah, that looks like about 300 words if you're splitting on spaces, give or take. Hopping back over the code, again, we've shown, just some real basics of Celery and Dramatiq, but I hope that this code samples have been like a good introduction to some of the use cases, specifically the second example where, hey, we're going to go and do this long running process of downloading the contents of a whole web page and then counting all of the amount of words in it. You could see where you might start doing some more interesting stuff. If you have a CPU bound process that's super intense, one of my examples earlier was some sort of machine learning that maybe you're also running from, and it can get triggered from an API. You might use Dramatiq or Celery to handle running those in the background. And something that you can do with both of them, as I mentioned earlier, is you can actually have multiple workers across multiple machines. In this case, I only have one worker in Celery, though I can scale that up. But all the workers are still just going to be on this local machine because I'm not using any like cloud provider or Kubernetes or anything like that to get too fancy with it. One other thing I'll show you is the Flower portal or the Flower UI. If we take a look at our container that should still be running, we can see that Flower is running. It's using localhost by default because we didn't give it any URL to use. Pull that out. Oh, maybe it's not running. Oh, so that's because we're running it in a Docker container. One thing we're going to want to do is to actually be able to access it outside of the Docker container is we're going to want to use port forwarding to 0.0.0.0. Let's open up our Docker compose file really quick, and that should be a quick change. We scroll down to Flower, use ports. We'll just use the port it's already running on, which looks like it's 5555. See if I can remember this syntax off the top of my head. So that should forward the containers port of 5555 to the host port of, I think I'm doing that right. This wasn't part of the demo, but let's see if we can get it working really quick. Go ahead and restart our Flower container really quick. And it's still restarting. You know what? We're actually going to want to run Flower itself on the web app running inside of the container. We want to be running on 0.0.0.0, and then we'll pass that port to our host. I don't know the Flower CLI off the top of my head, but we can take a look. I won't spend too much time on this, but let's see if we can get it working because it's cool to look at. If we do Flower help, because we should have that installed or not. Extra comma. Where are you seeing the extra comma?
That was from way before, not here.
Oh,
You don't. I think you just, but you do want just the 555. You don't want the 0.0.0.
Yeah, I agree. I'm just trying to remember. I haven't written the Flower part from scratch in a second. Let's go ahead and add command, and I think we should be able to do port for host 0.0.0. We'll just take a peek real quick at the documentation. I was having trouble getting it from the command line. Ah. All right. Last try. If it doesn't work, no sweat. It is a cool tool, but so we'll restart the Flower container after we updated the command it's running, and we'll make sure that it's running. No host name supplied, so that must not have been the right command. No worries. I'll get it working after the presentation, and I'll make sure the example code is updated so that if you're watching this presentation after when it's posted online, it works for you. Flower's cool, gives you a cool GUI, but you can also access all that stuff using the CLI. So, all right, let's hop back over to the presentation now that we've shown some code. That's not the right one. So one last thing I want to touch on before we call tonight is just a couple of best practices. All of these should apply to both Celery and Dramatiq, and when you're using other message brokers in general. One, pass a small amount of data as possible when you're using messages. You're generally going to want to favor, instead of, say, passing an entire object that you're working with, or maybe you're using in your background task that's running. If you have something like a database set up, or even an in-memory cache or something, prefer using an ID if possible, and just go ahead and retrieve that object inside the task. The messages are sent over the wire, so especially if you have a lot of messages going on, it's just a lot more data that's getting passed around. It's not preferable. It doesn't scale as well. Another thing that I didn't touch on too much, but I'll add to the sample code, but for the sake of time, we'll maybe skip it for now, is result backends. I did talk about it, but didn't show the code examples. Basically, you can store the results of your tasks in Mongo, Redis, Memcached, and more. The thing is, if you're kind of following step number 1, where you're not passing objects over the wire, then step 2 is kind of a natural change you might make as well, where you're not passing large objects in your responses back over the wire or at all. If you're using some sort of status property or something on the objects you're working with to verify when they're done or when they're in progress or something like that, or depending on your task, you might not even need to necessarily know when it's done. For example, if you're sending an email, if something fails, then you want to have some sort of notifier or watcher, like Sentry, watching to let you know. But if it succeeds, you don't necessarily care that it finished. You expect it to finish, and if it doesn't, it's some sort of anomaly. So if you don't need to use result backends, don't store the results of the tasks if you don't have to. Final thing is making your tasks indempotent. Basically what this means, if for some reason Celery or Dramatiq has something disconnects, or you restart them, or something happens where the task is getting either run and completed or partially run, and it fails and it's getting retried. Basically, you don't want your tasks to have side effects where you can't run them multiple times. You generally want to make your tasks able to be run, as many times as possible until it finally succeeds, without having side effects where you have something that's now broken. One example of this could maybe be if you're running a task that's doing some sort of manipulation to a model or an object in your database, and you start modifying that object midway through your tasks, but then the task fails maybe towards the end, and so your object's left in this weird state where it's not how it was before, but it's also hasn't finished successfully. That's maybe an example. There's probably some better examples that I'll think of, or if any of our wonderful viewers have examples, feel free to chime in. So those are just a few best practices. There's others, but the Celery documentation and I almost said pedantic, so used to using that library. The Dramatiq documentation both have some more. One last thing before we wrap it up, call it a night, is just a couple references to some other Python, messaging queue libraries or projects. I haven't used any of these actually. Celery and Dramatiq have been plenty to keep me busy, but these are some other options. Most of them aren't close to as popular, as Celery. A lot of them advertise as being a lot simpler than Celery. The one thing that you will notice quickly about Celery, if you start getting really deep and down into it, or you want to do something like create a pull request for it, is it's actually, most of its code is kind of spread out between multiple code bases. There's the Celery code base, there's something called Kombu, which it uses internally, and there's a third code base. And so it's not the easiest code base to jump into, and it's fairly dense and complicated. So a lot of these other Python messaging queue projects or libraries are trying to make a bit of a simpler version. Dramatiq is just one code base. A lot of these other ones are a single code base. I think one of these, maybe it's Hui or Kyruk, is actually just one file. It's that simple. And then the Django caret is Django specific. The one that I think is most interesting, though I haven't used it, is Taskmaster. Its goal is to be able to do like one-off tasks, like maybe doing a database migration that only needs to happen one time. If you weren't using Django, which I think has database migration stuff built into it, or other one-off tasks of that nature. So that one's worth interesting, probably the one I would go and look into if I was going to check out one of these. That brings us to the end of our presentation. I think we're coming up right about an hour, so we'll call it good. Are there any questions, comments to our viewers? Good stuff. All right, appreciate it, Phil. Well, please press the comment button, smash that comment button, leave your questions below, or comments, critiques, all is welcome. And one last time, I will plug our feedback survey. Would love to hear what sort of topics people in the Spokane Python User Group want to hear, whether that's machine learning, data analytics, more API stuff. I'm down for talking about anything. Or if you're interested in doing a presentation, that's great. Let's get connected. I'm willing to co-host with you. If you want to host by yourself, we'll get something worked out. If you want to do a lightning talk, where it's just kind of a quick 5 to 10 minute presentation on a maybe a smaller topic or something that's quick to cover, that's welcome too. All right. Here's a couple references for more resources, and then obviously the Celery and Dramatiq documentation itself, which are linked earlier in the slides. With that, thank you everyone for coming. Much appreciated, and look forward to seeing you next time.